Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. In this module, basically, we are trying to understand how the operating system manages the CPU by providing the abstraction of a process, right? So within this module, currently we are on the first topic, that is process introduction. And here through a series of videos, we are trying to understand what exactly is a process and how the operating system implements this abstraction in the computer system, right? So in the previous video, we defined the term process. We now know that a process is a running program, and we also saw the difference between a program and a process at a high level. And now what we are going to do in this video, there are many more differences that are there between a program and a process, and in this video we are going to see the differences in more detail, right? So let us understand how a program is different from a process in more detail. Let's get started. So let us quickly recall what we had studied in the previous video. So there we had also studied that basic difference between a program and a process. After recalling this, once we have done this, then we can delve deeper and study the differences in more detail, right? The other differences. So in the previous video, we studied that it all starts with the source code. The source code is a file which you write in some high level programming language like C, C++, Java or Python. And this language, this high level language, is somewhat similar in syntax to the natural language like English, right? So you can see the English words here, and this is understandable by the human, the programmer. Now, before we can do anything with it, first of all, we have to compile this source code into something which the machine understands, and the machine understands only ones and zeros. So first of all, what we have to do, we have to compile this source code into machine code, right? Machine code means binary format, zeros and ones. So what happens when you compile the source code is that all of these statements that are written in high level language, these are converted into instructions and data at which are in binary format. And this collection of instructions and data is what we collectively call a program. So what is a program? A program is a collection of executable code and data. So executable code and instructions mean the same thing. So these are instructions or code which the CPU first of all understands, and it executes them to manipulate the data that was also generated in the program. So this is the program, and this is a file. This is a passive entity. There is no activity going on. So once you have compiled your source code, you have generated your program. It's a file which is in binary format, and it is sitting on the disk. Now what we have to do, we have to run this program, and when we run this program, that is when it becomes a process. So a process is a running program, and when a process is running, right? So what happens, the instructions of the program that were generated, they are getting executed, data is being manipulated, and you can see the activity, you can see the results on the screen. You as a user can provide some input and see the output. So this is an activity that is going on. So that is the basic difference between a program and a process, right? A program is just a file, and a process is a running program. It is when we launch that program, it becomes a process. The program is a passive entity, right? And the process is a active entity. So these were the basic differences that we studied in the previous video. So now we are going to look at the other differences that are there between a program and a process. So in order to really understand the difference between a program and a process, I have a very interesting analogy to for you, right? So as you can see this slide, there are two pictures. On the left we have a music CD, and on the right we have a music player playing that CD. And uh, the point is that this music CD or this music record is very similar to a program, whereas this music player playing that CD is similar to a process. And you can see the intuition behind this analogy. If you look carefully at the music CD, it is just a file or storage medium on which the music notes have been recorded, right? There is no music being played in the first case. This is very similar to a program. It is also the program is also a file in which some information has been stored, for example the executable code and the data, right? So both the music CD and the program are files in which some kind of information is stored, but no activity is going on. In the case of the program, although it stores the instructions, it is not being executed. Similarly, in case of the music CD, although it has music notes, the music CD in itself does not the music does not come out from the music CD unless you put it on the music player, right? Coming to the second part of the picture, this where this picture where the music player is playing the CD or the record is something like a process, right? You can see the similarity because when a process is a running program, that is when the CPU starts executing the instructions to manipulate the data, and these instructions and data were part of the program. When you start running the program, that is when some activity is going on, some useful work is going on, right? In the same way, when you put the music CD on the music player, that is when the music player starts decoding the notes that were recorded on the music CD, and then you can hear some music, right? So this is the basic analogy that can help you understand the difference between a program and a process. A program is very similar to the music CD. It's just a file, it's a passive entity, and the process is very similar to this music being played, where some activity is going on, right? So this was about the analogy. Let's look at some more differences between a program and a process. So this slide contains all of the differences that we want to talk about between a program and a process. So the first two differences, we have already looked at them, but I'll quickly recall them once again. So the first difference is about the definition, right? So what is a program? A program is an executable binary file residing on the disk, whereas a process is a program running on the CPU. So as you can see, the program is just a file. It contains the instructions and data in binary format, and it is residing on the disk. It's situated on the disk, whereas a process is a running program and it is situated on the CPU, right? So this was the basic difference, the definition, and you can relate this with the analogy that we just discussed. So the program is very similar to the music CD, just like the program, the music CD is also a file on which the music notes have been stored, and the process is very similar to this music being played, where the music CD is actually being played just like a program is being executed, right? So this was the basic difference, the definition of a program and a process. Then the second difference that we looked at is the nature. So the program is a passive entity. As such, no activity is going on when you talk about a program. It's just a file, right? Very similar to the music CD. Just the notes are there on the CD. No music is being played. And a process is an activity which is very different from the nature of a program. So when you talk about a process, there is a whole bunch of activities that is going on. For example, the instructions are being executed, the data is being processed, and as a user, you are interacting with the process, right? You can give your input, you can see some output. So all of these activities are associated with the process. And in the case of a program, there is no as such activity. Similarly, let's come back to the analogy. When the music is being played by the music player, you can see that the CD is rotating, the notes are being decoded, and finally the music player is playing that music. You can hear some beautiful music coming out from the player. So this was the second difference, the difference between the nature of a program and a process. So let's look at some other differences also. So the next difference that I want to talk about is the lifespan of a program versus that of a process. So as you can see, the program has a much more longer lifespan as compared to that of a process. So the reason is that the program resides on the disk, and when you want to launch it, it has to be loaded into the memory. That is when it becomes a process. So the program is on the disk, whereas the process lives in the memory. And the disk is a persistent form of storage, whereas the memory is volatile. So when you shut down the system, then all of the contents of the memory will be lost, right? So since it's a volatile memory, it depends on the electricity. So when you shut down the system, all of the processes that were there in the memory, that way they will no longer exist. Whereas that is not the case with that of a program. The program will still be there on the disk. The disk is a persistent form of storage that can store data even if you shut down the system, right? So you can see the lifespan of a program is generally much more longer than that of a process. First of all, due to the differences in the nature of the storage devices that they live in. So programs resides on the disk, whereas the process lives in the memory. And whenever you shut down the system, process will be lost. Another reason why the lifespan of a program is much more than that of a process lies in the way in which we use the program versus that of a process. So the first thing that we do is that we write our code and then we compile it to get the program, the executable code and the data, right? Or you might not write your own code, you might download it from the internet. So whenever you're downloading any piece of software and installing it in the system, you are basically downloading the program file. So this thing happens only once. Writing of the code or downloading the software, installing it, this happens once. And then what we do, we use the same program file again and again to launch multiple instances from it. We launch the program, we use it, then we close it, right? Even within the same computer session. When I say computer session, I mean the time from which you boot the system to the time you shut it down. Even within the same session, you will be launching the multiple instances of the same program and terminating it, right? So even if you don't shut down the system, when you terminate a process, the process gets terminated, but the program is still there. We don't remove the program file every time you terminate the process. The file remains still there on the disk. It's just that we have terminated the process, we have terminated that particular instance. So if you see the way in which we use the computer system, we install or write a program once, and then we use the same program file multiple times to launch multiple instances of the process. We only terminate the process, right? So this is how you can see the lifespan of a program is much more than that of a process. So this difference between the lifespan, we can extend this difference point to our analogy as well. So this music CD, which is very similar to a program, this is produced only once, right? But we can listen to it multiple times. So let's say you listen to this music every day. So that activity is short-lived. You every day, what you do, you start the music, you listen to it for some time, and then you close it. But when you remove the music CD from the player, it does not mean that the music CD gets destroyed. If it's still there, the music CD is still there, right? So you can see the lifespan of the music CD is much more than the activity of playing the music. You can play the music every day, you can start it and stop it, but even if you stop it, the music CD is still there. So this difference between the lifespan extends very well to our analogy as well. So the final thing is that the lifespan of a program is much more than that of a process. The next difference that I want to talk about is that of resource usage between a program and a process. So if you look at a program, then the only resource that it requires is some space on the disk. Since it's a file, all it requires is some storage space, right? Right. But when you compare this with a process requires a whole bunch of resources. It's a running program. So first of all, it requires the CPU in order to execute the instructions of that program. Then it also requires some space in the memory, because that is where the data and instructions of the program will be residing when it is executing, right? So the process requires memory, and it also requires disk, because it might be creating some file, reading or writing some file. So whenever there is any interaction with files between a process, then we require the disk. And finally, when the process is running, the program is running basically, when you talk about a process, then the user will be interacting with that process. The user will be giving some kind of input, they will be getting some kind of output, right? So this input and output interaction happens via IO devices. So all the processes requires IO devices as well. So you can see the difference between the resource consumption of a program and a process. A program is very simple in this sense. It only requires some space on the disk, whereas a process requires a whole bunch of different resources like CPU, memory, disk, IO device, basically all the hardware resources that are there in the system. And if you go to the task manager, if you're on Windows operating system, so let me show you. In the task manager also, you can see these are all the processes that are there in my system, and the task manager shows you the resource consumption for each process, the CPU, the memory, right, disk and network. So you can see a process is a resource intensive entity as compared to a program. And in our this music CD analogy also, you can see that the music CD, all it requires is that CD, right? That is the space it requires. The music notes have to be stored on the CD, that's it. But if you want to play the CD, then require a music player, right? So it requires a resource. So this was the difference between a program and a process, in this sense, that is, program has very less resource requirements. All it requires is some space on the disk, whereas if you talk about a process, it requires literally all the some share of all the hardware resources in the computer system. The final difference between a program and a process is that of utility. And I guess it's the most important difference. So a program by itself is of not much use unless you run it. Only when you run the program, it becomes a process and some useful work happens. The very purpose for which you wrote your program, that is to process some kind of data, that processing will only happen when you run that program, right? When it becomes a process. So this is a very fundamental difference between a program and a process, is that the program by itself is of not much use, whereas when you run that program, that is when some useful work is done for the user. It's very similar to the music CD analogy. If you're composing music, if you're producing music CD, but you never play that music, then what was the point of like composing that music? Only when you play that music on the music player, that is when the music comes out and we enjoy the music, right? So playing the music is what renders utility to the music CD. You don't want to be a programmer who writes code that nobody runs, or a music composer who writes music CDs that nobody listens to. That would be a pretty sad state of affairs, right? So this was the difference of utility, and the final difference between a program and a process that I wanted to talk about. So guys, this was it for this video. In this video, we talked about the several differences between a program and a process. Now we have a very good understanding of what is a program and a process, right? So now in the next video we can start talking about how the program becomes a process. So guys, this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.